Okay, so we're going to start with our pesticides. These are pesticide notes. This is video 1, probably video 1 of 1. If it starts to get long, then I'll stop it and make it into 2 videos so that it loads okay. Okay, so a lot of this is straight vocab. That's why we started with that vocab stuff to let you take a look at. But a biological pest is anything that reduces any quality of resources, availability of resources, anything that impacts negatively our available resources. Pesticides are anything that kills pests. Okay, so the history of pesticide use, it's been around for thousands of years. Sumerians used it, the Chinese used it very basically, Greeks and Romans used it. So this is not a new concept. This has been used for a long time. That's a lot of the reason that there's a lot of spicy food actually in the tropics, because they used it for preservation. The bugs didn't like all those spices stuff, and so if you put a lot of spice into your food, it would stay preserved for longer. It's really more recently that we've started to get into the synthetic chemicals, and that makes sense. As you know, our technology has developed, we've been able to make and create more and more stuff, and therein lies the problem. Plants themselves actually have, when you think about it, really highly evolved natural pesticides that they use. Some plants even secrete like acid-based stuff to use as a pesticide. So they have a lot of natural of their own defenses to use against pests that we have taken and kind of spread from that. So there's lots of different types of pesticides. Again, this is straight vocab, so I'm going to go through this pretty fast. You guys have it already. Biocide is a broad spectrum, kills everything. Remember, make sure you understand broad spectrum is like a general term. So refers to a lot of different species, a lot of different groups. Herbicide kills plants. Insecticide kills insects. I mean, these are all really, really self-explanatory. Nematodes is worms, rodents like mice and rats and stuff. Okay, agricultural pesticide use. Herbicides were by far the most, and then insecticides, very strong presence as well. So we generally try to take out weeds and try to take out bugs, and then everything else is a relatively minor proportion. So the classifications: first generation are the natural compounds that taken from plants. For example, sulfur. Second generation is stuff that we have created, that we have made, and that's was started really in 1939 with DDT and malathion. So that broad spectrum, like I said, affects many species. The narrow spectrum only affects 1 or 2, very selective. Okay, so inorganic, be able to give an example of an inorganic versus an organic pesticide. The inorganics, a lot of the metals, very, very, very highly toxic to people as well. So it's not, this is a broad spectrum. It's not going to kill specific stuff. It's going to kill anything pretty much that it comes into contact with in enough concentration. The point is that we can put a little bit out there and it kills the bugs because they're little, but then as we get it built up in our system, then it becomes more and more toxic to us. For example, the mercury that we're using in pesticides is building up as it comes up the food chain, and so a lot of fish is considered to have too high levels of mercury. So I don't know if you guys have ever heard, but they'll say don't eat, especially women, having children or possibly having children, don't eat a lot of like striped bass, don't eat a lot of tuna, because there's a lot of mercury in that. It's built up in their systems from eating so much of the little stuff that has the mercury. That's what we were targeting. So that now that mercury is toxic to us at those levels if we eat too much of it. And so we could get sick ourselves or have children with birth defects, stuff like that. The organic pesticides are much calmer, less toxic, more natural. Obviously, they're organic, and then tend to be a little bit more narrow spectrum. We extract them from plants. They're all toxic to insects, and then some of them to humans or fish. Fumigants are sprays. So they're small molecules. They evaporate quickly, but they penetrate really far because they're small, so they can get into tinier spaces. They're used to sterilize like soil or grain infestations, so they're specifically used against insects, but they're really dangerous for the people that apply them, and so most of them are now banned. There's just no way, if the wind blows weird or whatever when you're applying it, there's no way to control really what it's getting on. Hydrocarbons are synthetic. These are one of the really dangerous ones, really gross ones. A lot of these have been banned as well, like DDT. They're act against nerve transmission, highly toxic, very fast acting, and they stay for a long time and stay concentrated in the food chain. So this is what the DDT is what made Rachel Carson famous with her book, The Silent Spring, and she was looking at the DDT concentration building up and building up. Okay, organophosphates. They started with nerve gas research in World War II and now are used for pesticides. That right there should have been a clue, I would think. They affect the nervous system, toxic to animals, birds, and fish. Much more poisonous than the chlorinated hydrocarbons. Very, very dangerous. What's up? Okay. So we already talked about organophosphates. Sorry, quick interruption. Okay. The carbamates and urethanes are similar to the organophosphates in the way that they work. Different chemical structure. They actually focus specifically on bees, so they're very, very narrow spectrum. And then the contact and systemic. So contact would be like if it touches your skin. Systemic would be an internal thing if you're eating it and doing whatever. That'd be like the stuff that you see a lot, like Roundup against weeds. Okay, so biological controls. This is a much more natural way of doing this, and this is where you see a lot of the integrated pest management plans. A lot of the times we'll use less pesticides and use more biological controls and try to fight fire with fire, per se, which is great, but it has to be used very carefully, because sometimes that can really backfire. But for example, a lot of the biological controls use like a wasp to eat mosquitoes, or like ladybugs to eat plants, or vice versa, so that you get really very natural, and you're not adding any chemicals into the environment, you're just simply controlling stuff. So this is a great alternative to using the really heavy chemical pesticides. Okay, so the benefits to pesticides, we've talked about this already when we did the case study. It's disease control, because the insects carry a lot of diseases. So the insecticide control has prevented 50 million deaths over the past 50 years. So that's pretty substantial. I mean, that's not something to turn away from. What have we learned? Crop protection. It's lower prices. It's the way that we eat today. We've looked at Food Inc. We've talked about that. The way that we eat today, the way that we demand that our food is taken, demands the use of pesticides and demands the use of those harsh chemical-based pesticides. So there's, looking at it purely from an economic, I think, really in my opinion, the overall pesticide problem is balancing the economic need, where it makes things cheaper and more cost-effective. So the economic need versus the environmental and the health need. They're really bad for you from a health standpoint, but they're really good for you from an economic standpoint. So it's trying to find a balance there that is really the challenge. And that may be a different balance depending on where in the world you are. Okay, so they work faster and are better, easier to use, quick and cheap, long shelf life. Very, very self-explanatory what all the benefits are. Most of them are broad spectrum. The health risks are getting better. We have banned a lot of the really, really bad stuff, so that's good. There are less harmful ones being developed, so that's also good. So it's improving. The problems with I'll spit it out. The problems with pesticides is the genetic resistance and the resurgence. This is a big deal right now. So we almost never get, one spray of a pesticide is not going to kill 100% of the pests that you're trying to get rid of. It's going to kill, depending on the pesticide, 50%, 80%, 90%, whatever. So it's great, it's very helpful, but they're going to have to keep coming back, which means that you are going to have to keep spraying, keep applying that pesticide. So the ones that got sprayed and survived end up having a partial resistance, which means that as you continue on, over time that population becomes resistant, which means that at some point the pesticide you're applying is no longer going to have any effect on the pests that you're trying to control. So the resurgence is a quick rebound of a population with resistant individuals. So you see these cycles where you get the application, you see a drop off, and then you get a rebound, a small rebound, or as the population starts to grow back up, you apply more pesticide, and then you see here with this much higher, resistant population, the overall population is now higher. So you really end up in the long term having a bigger problem than you did before you started even applying the pesticide. In Peru in the 1950s, DDT increased cotton crop yields, but the weevils were a really big problem. Okay, and I guess that was it. So let me go back to that. So the weevils were a really big problem. So you end up, so they apply, I'm sorry, I said that really wrong. They used DDT initially to spray for the weevils. The weevils disappeared and the cotton crop yields increased initially. But then the weevils came back and were resistant. So now it's a bigger problem than ever. Now we can't use DDT anymore because the weevils, it doesn't work, it doesn't kill them. So what are we going to use instead? Okay, so the treadmill is that resistance concept, that cycling thing. Try increased doses, different pesticides, more toxic forms in order to keep ahead of the pests. It's this vicious cycle. So even though we're using more and more pesticides, the crop loss is now starting to increase. So there was this initial thing, when we first started using this in the 30s, 40s, 50s, where pesticides were great. They were working really well. They were beautiful. It was awesome. Our crop yields were great. Life was good. But now we're hitting that resistant part where we have bigger problems than we had when we initially started, and the pesticides are not really working as well as they did anymore. So even though we're still using more and more pesticides, we're still losing crops to pests more and more today compared to 1940. So it's that resistant thing. It's a vector transmission. Okay. So the non-target species, this is also a huge problem. So not only does the pesticide kill what you're trying to kill, but it also kills everything else around it, because most of these are broad spectrum. So most of the pesticides don't make it to the intended target, which means that we're losing a lot of native species to pesticides that we don't necessarily want to. So this is loss of biodiversity. We have spills, we have accidents, which are accidents, but they have to be taken into account, and you have to think about that. What is the effect on the whole ecosystem that you're trying to maintain? And this is where I'm saying that the economic balance has to balance out with the environmental balance. So picture of a large-scale farm spraying pesticides. They do it from plains quite a bit over farmland. So the problems is creation of new pests, removing the natural predators. So a lot of the time, that broad spectrum doesn't kill what you want it to, kill something else. Well, now whatever that something else was eating is now growing, and now we have a new pest because the spiders aren't there to keep it in control anymore, something like that. So there's further and further effects. It's pretty interesting. 100, so a full third of the most destructive pests we have in the U.S. weren't pests originally, but because we started using pesticides, they became pests. So that's something definitely to take into account as well. Is this really, in the grand scheme of things, how much are these pesticides really helping us? So you see the numbers, creation of new pests, persistence and mobility. How long are the pesticides staying, and how far are they moving in the environment, is what those two mean. So So stuff like DDT is a huge problem. We stopped using DDT in the U.S. like 20 years ago, at least, more like 30 probably, and it's still around. It's still in eggshells. It's still in insects. It's still in the soil. It's everywhere. It has a really, really long persistence. It has a really high mobility. It's spread. It permeated through almost everything, and it's still there, and we're still trying to get rid of it. Well, there you go. Banned it since 1972, so almost 40 years, and we still have DDT in our bodies, even though most of you guys weren't even born when it was in use. I wasn't even born when it was in use, and I'm super old. Okay, pesticide rain is the movement of pesticides by air currents where no spraying has happened. So you spray this stuff, and half of it gets picked up by an air current and taken somewhere else, and then sprayed and has really negative effects. So threat to animals. Okay, so this bioaccumulation and biomagnification are really, really big concepts. So bioaccumulation is the buildup of levels of the pesticide in the body of whatever species you're trying to look at. So accumulation is a buildup. So that's what I was talking about. The mercury is building up and building up the food chain. So there's a lot of mercury. The plankton are eating it. The fish are eating the plankton. We're eating the fish, or dolphins are eating the fish, whales are eating the fish. And so by the time you get to the whales, there's these huge levels of mercury in their bodies from that bioaccumulation, because they've eaten so many of the little animals that have just a little bit of mercury in their bodies. The biomagnification is transferred up the food chain. So the concentration increases and increases. Okay, so the DDT I've talked about already is a good example. Shows it here, same concept that I just talked about with the mercury, so make sure you look at this and understand it. As it moves up the food chain, you have more and more and more concentrations. So before the ban in 1971, the predatory birds especially were hit really hard. They had very high levels, caused their eggshells to thin out, and so the birds, when they would sit on the nest to keep the eggs warm, would crush their own eggs, and so you saw high fatality, high mortality, and a lot of those species becoming endangered species. Okay, even though we don't use it, we still make it to ship to other places, so explain to me why that makes sense, because it hurts my head. And you guys know already, animals don't observe country boundaries. They move it around. They're exposed to it still. It's still legal in some places. Many of the endangered species are recovering, not all of them. Okay, so in human health, the short-term effects is, if you get hit with a strong case of it, an acute poisoning case, if you get sprayed with a lot or eat a lot or a high dose of some way, there are 220,000 deaths from pesticides every year, humans. So again, from an economic standpoint, is the money really worth it? Long-term effects, cancer, birth defects, and immunological problems. Low-level long-term exposure that builds up, and that's that biomagnification building up in your system. So you see farm workers applying by hand. So in human impacts, you see behavioral changes, biological controls, genetic engineering. These are the big concepts for alternatives to pesticides. So this is what I was talking about, where rather than using the chemicals, the heavy chemicals, what else can we do to get rid of the pests that we don't want and still have, still improve our health? So there's behavioral changes of the animals. So a lot of it's doing like birth control for insects. It sounds crazy, but sterilizing. Can we not kill them? Can we sterilize them so they're not, reproducing as much? Can we lure them somewhere else with pheromones and hormones? So behavioral changes, our behavioral changes. Can we plant at different times? Can we, change what we're doing, our system, just a little bit so that the pests don't impact as much? Biological controls, there's a lot of stuff like using hot water or using material like I used to work on a farm, so we would actually put down, rather than spraying pesticides to keep the weeds down, we would put down plastic and have holes in the plastic and stick our plant, like our tomato plant or whatever, through that hole. So the tomato plant can grow really well, but the plastic covers everything else, and so everything else is not getting sunlight, and that keeps the weeds down. So stuff like that, biological controls. And then the genetic engineering, which we've talked about already. Water, I said, irradiation to kill stuff, to kill bugs especially. And then this integrated pest management plan is what I was talking about, where you come up with this plan that has a lot of these controls, maybe perhaps a small amount of pesticide or very controlled levels of pesticides, plus 3 or 4 other factors that control stuff. So what I would strongly recommend to you guys is going through each of these things. And in fact, I will offer you extra credit for you. If you bring me 1 page on Monday, let's see, I'll tell you what. If you bring me 1 page on Monday that has 3 or 4 sentences explaining each of these things and how they're used to control pests, you don't have to take your quiz. You get a 100 on your quiz grade, and you don't have to take your quiz. So, there you go. Okay, behavioral changes. Crop rotation, mechanical cultivation, flooding fields, burning crop residues. So this is all examples. How do you put it together? Okay, so I'm going to go through and let you talk about it, figure it out yourself, because that's your assignment. So this is the problems with biological controls. Genetic engineering, we have some options here. Let me go back so you can see it. Remember, you can pause this. Looking at insect birth control, hot water, spraying hot water, irradiation. So you guys can go through and talk about this in your paper and not have to take your quiz if you go through and write this up for me. Let's see how many people actually watch this. So the integrated pest management plans. And regulation. Okay, so now we get into pesticide regulation. There are 3 agencies that control it. The EPA. So again, this should look familiar to you from your vocab. So the Federal Insecticide, Fungicide, Rodenticide Act registers all pesticides, so we have to. So the EPA controls, the Environmental Protection Agency controls all registered pesticides, and legally every pesticide has to be registered. And sets tolerance levels, how much you can spray, how often you can spray it, and how much, therefore, is safe to eat. The FDA and the USDA are responsible for enforcing those tolerance levels and stuff. The problems with all this is that not all of it is well controlled, not all of it is tested well. And then there's inert ingredients that also have effects that aren't really controlled at all. You know, we always look at the active ingredient, but then what else are they putting in that stuff that you're spraying out, and what effect is that having? And there's a lot of loopholes in the laws at this point in time. So the laws definitely have